When you program in C, the first thing that happens is the compiler converts your code to assembly language. And the assembly language then starts dealing with physical hardware, and it deals with also things like, is this number less than that number, greater than that number, any conditions that you have in do whiles, while loops, for loops, whatever, are based at the hardware level in terms of N, Z, V, and C. Now we've already looked at the N bit. For signed numbers, a 1 means that yes, this number is negative. For a 0 it means no, it's not negative or positive. For unsigned numbers, it doesn't matter because all the numbers are positive, so this is only for signed numbers, so the N bit is a signed bit. We also have a 0 result, or Z bit, and the Z bit is for just 0. 1 says yes, the answer is 0, it's true, and for all other numbers, not 0. And the reason for this is when you use counters and so on, it's only important when you hit 0, not for any of the other numbers. For all the other numbers that aren't 0, Z is 0. Only for 0 is Z a 1. Now the other two bits have to do with signed and unsigned overflows in terms of numbers and calculations going past your number system's ability to actually represent the result. We're going to look at that next. So far we've been doing additions to generate a result. We've been doing subtractions to generate results. We've never asked ourselves, are these signed or unsigned numbers we're adding and subtracting? We're just numbers and we come up with a result. But now it's time to actually take a look and see if these were unsigned numbers, does the result make sense? Now if we look at the equivalent decimal values here and consider them to be dollar values, FF is 255. It's saying, okay, I've got $255. Somebody gives me another dollar, and I got $0. Now the real result is 100, which is correct, but when we're using unsigned char, it's only 8 bits, which means this much, not the carry. So we're losing this information and only able to now deal with these 8 bits here. So that's a problem. Also notice here, if we have 3 subtract 5, that means I go 3 units in this direction, I go 5 units in the opposite direction, and I end up with FE, which is 254, which means I had $3, somebody took away $5, and now I have $254. Makes no sense. Let's take a look at these same calculations down here. FF plus 1 is 0. Not a problem. 3 subtract 5, 3 units this way, 5 units this way, ends up with FE, and FE is minus 2. Perfect. So these calculations don't work in the unsigned, but they work quite nicely in the signed char region. So anytime we see a carry or a borrow, what this really means is we have an unsigned overflow. And an unsigned overflow occurs if you add two n-bit numbers and get n plus 1 bits, or subtract a larger number from a smaller number. So here we are subtracting a larger number from a smaller number. That's a problem because typically you're going to end up with a negative, which you cannot fit onto an unsigned char line. Now when we're talking about n-bit numbers here, in our case we're talking char, so if we add two 8-bit numbers and generate a 9th bit, which we've done here, or if we have a short and add two 16-bit numbers and generate a 17th bit and so forth, that again is an unsigned overflow. Let's take a look down here at the 8-bit signed char numbers and 7f plus 1. Now notice 7f plus 1, let's take a look at it up here. 7f plus 1 is 80, and notice we have no carry, which means that's a valid result. So 7f plus 1 is 80, no carry means that it is a valid result unsigned. But let's take a look at this same calculation as a signed number. And again, let's use these numbers to indicate dollar amounts. So I start off with $127, somebody gives me another dollar, and I'm $128 in debt. Oops. Or let's look at this one. I'm as far in debt as I can go, minus 128, I go another dollar in debt, and now I have all the money in the universe. That doesn't work either. So certain calculations will work here, as long as the carry is not 1. Other calculations will work here, as long as the V bit, which is a signed overflow, isn't 1. Let's see what that means. 7f is positive, we add a positive, we get a negative. So if we add two positives, you'd expect to get a positive, and when you don't, that's a signed overflow. This is a negative plus a negative, giving us a positive. So if we add two negatives and get a positive, that is a signed overflow. So the concept of signed overflow occurs if you add two numbers of the same sign and generate a result of opposite sign.